All right, ladies and gentlemen, we're continuing our terpene discussion. Classification of terpenes is pretty simple. It's based on not the number of circles, the number of carbons in multiples of 10. So if you have just 10 carbons, number of C's, class. And 5's too small to be a terpene. So the first one is 10. Monoterpene. Oh, this is going to be easy, isn't it? Leave room for 15. 20, though, is twice as big as 10. Take a wild guess what the classification is. Say it again. Diterpene. We'll come back for 25. We'll do 30. Yeah, we're doing the easy one. It goes to 40 for us, okay? Take a wild guess. Yeah. The 5s all start with the same letters. And you'd think the smallest one should go first, right? No. Smallest name should go first, right? No. Smallest name goes third, right here. Sesqui. Sesquire. It sure looks like a 4 in there, doesn't it? There ain't no 4 reference to solid at all. And some older books even call this one Seth terpene, just to make your life miserable. They throw Seth in there twice. I don't know why. So this is all the classifications you need to know. And guys, you can use the circles, but remember, you need 2 circles to get 10, right? Because each circle's 5. So I think we had 4 circles here. 1, 2, 3, 4. That's 20. We're class. Diterpene. Baby blue. 5 circles is the, no, yeah, 5 is the bottom one. The 25, which one was that? It disappeared. Terpene. Okay. Now this side of the page is kind of full, so I have the same terpenes here for you. This will happen on your test too. It's always the same format. Let's do these parts over here. Determine how many possible stereoisomers exist for each molecule. Aren't we supposed to put an asterisk on all the stereos? Oh, I didn't have the top of the screen. Sorry. Star and all stereoisomers. Let's do that first. You can't do part F before you do part D. Look familiar? I know. Your performance on this for your first time using stereo centers, I was happy. The class did pretty good on picking stereo centers. It's a new thing. It's hard. Especially when there's no, the H's don't show and you got to remember, oh, there's an H there. Yeah, that's a group. Oh, darn, I missed it. All right. So we got these things. All right. We have 2 to the power of, did I do them all? Did I miss one? I think I got them all. I think I got them. Is that 7? Don't start tripping on me, guys. Don't start freaking out. I know, no calculators. Why does it keep doing this to us? Ladies and gentlemen, part 1 of this exam has all the powers of 2 in order as the answers to one of the questions. Your exams till the end of my tenure here at school will always have those answers in a row. So let's just quickly get our exam if I can find it. That's an exam. Perfect. Page 2, 3. You see this one right here. Those are 2 to the 1, 2 to the 2, 2 to the 3. Got it? Any 2 to the 7? Pick the 7th answer. Was it 7? It was 7, right? Yeah. 1, 2, 3, 4, 5, 6, 7. 128. And I think the next one, just 128 for now. 2 to the 7 is 128. I didn't have to do math. It's here. Okay. Why did I do that? Oh, each stereo center has a possibility of R or S. That's where the 2 comes from. 2 raised to the power of that many possibilities gives you how many possible isomers there are. Yeah. There are 128 combinations of RSR that gets to 7. There are 128 ways of doing that. Start with all of them R. Then there's 7 combinations where one of them's S, right? And then you don't work on that. You'll get old before your time. All right. So, oh, I got another question I never asked, but it's a good question. Take a wild guess of the 128 isomers that are possible, how many do you think exist in nature? 1. Now, how is that possible? Each stereo center manufactures and only one combination of stereo centers get assembled. How come? Because enzymes are doing it. Enzymes are handed. They're handed. So they only know how to put that stereo center one way. Okay? And then there's another enzyme maybe for the next stereo center. Or maybe they all get assembled at once and they fit in nicely in the active site, only with one combination of stereo centers. It's kind of nice. Doing my stars here. I think it's going to be more than 7 this time. We're going to be going back to that page, aren't we? Maybe we're not, though. I mean, sometimes it's fun to do a little math. You want to go back. What is it, 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to that page. I go 256, 512. That's what I'm doing. But, you know, I like numbers. Not everybody does. I know that. 2 to the power 9. You look for the ninth answer on that page. 512. So this became 256, and then that by 2 again, and it's 512. Okay, and functional groups before we go. I think that's part E. There's a bonus functional group. I didn't even mention it's a bonus. Oh, man. Huh. I mean, based on what you know, what's your best guess for this functional group? You guess amide, right? Because the nitrogen is attached to a carbonyl. I never told you what happens if it's attached to 2 carbonyls, did I? So I'm going to say it's a bonus. Because it's a 242 mechanism. The mechanism. It's a 242 functional group. It's an imide. Come on. Spelling is so critical with nitrogen, isn't it? It looks like amide, doesn't it? But when it's 2 carbonyls, it's imide. I'll give you the most popular and most notorious one. Thalidomide has an imide in it. Thalidomide, that's the drug for the morning sickness that also causes birth defects. Yeah. What about this one right here? And here. Yes, secondary alcohol. And I think that's the only 2 on that one. What about this guy right down here? Ketone. Now, I could have put an arrow from alcohol to this other one, but it's not secondary, so I think it's best to do something else. What is it? Tertiary alcohol. What do you call COC? And neither C is a carbonyl. Ether. Good. I was pretty happy with your functional groups too, everyone. I was. You did a good job. All right, and did we knock off our terpene page? We did. So do your best to get all of that done. You don't need the classification list down there. It's straight out of the textbook. But I need all the circles. Don't need the numbers really, but I do need the numbers that are written outside the circles. And I mean, they gave us the numbers to give us these. So you really should do the 1, 2, 3, 4 because it helps you with the connection question. And then make sure you copy the stereo centers and the functional groups. And that's all for today. I guess we had a lot of technical issues this morning, huh?